So I have here for you a review of Unit 3. This is the same review that I gave to you in class. I wanted to take some time to go through it and hopefully answer any questions that you might have, especially if you're not going to be in class for whatever reason. To prepare for the test, I wanted to give you a few helpful hints just to kind of help you get ready, know how to study. The first thing that you can do is to work through the review questions. Note any questions or things that you're not sure how to do. Make sure that you ask about those. Make sure that you either find the answer in your notes, ask the teacher, ask a fellow student, find the answer for what you're not sure how to do. Take some time to review your notes as well. Be sure that you kind of understand the topics from each lesson. So each lesson that we did, check out the learning targets and make sure that you understand those learning targets because that's what the test is written off of. Lastly, if you haven't already, do your assignments. Completing your assignments is a really great way to practice and get some extra practice before the test. If you're one of those awesome students who has kept up with your work and you've done the assignments, go back and pick one or two from each assignment and just try them. See what you remember, see how you do. That's a great way to sort of prepare and get some extra practice for the test. Okay, so those are kind of my helpful hints to help you prepare for the test that you will be taking this week. So here's our first question. Given a graph, find the asymptotes and state the domain. Remember that the domain is simply the values that cannot be part of the graph. That's where the asymptotes are. So it looks like I have an asymptote at, x does not equal 0, and I have an asymptote at, oh, hold up, I'm on the wrong graph. Here we go. At x does not equal 0 and at 4. Remember that when we state the domain, it's all of the values except the ones where the asymptotes are, where the graph does not exist. Nicely enough, that's also where my vertical asymptotes are. Please remember that they are separate equations, okay? X equals 0 and x equals 4. Those are both asymptotes of the graph. They need to be written as lines, okay? They're not a point. They are not x equals 0 and 4. You have to write them as two separate lines. You can also see on this graph that I have a horizontal asymptote at y equals 1. Okay, so we're just looking at the graph. We are finding the asymptotes and we're telling what values that the domain cannot be. Let's try another one. I already started this one. Let me erase this real quick because I was writing the wrong thing here. So let's look for the values where the domain does not exist or where we would have asymptotes. It appears that there was one at -1 and it looks like there's one at probably 2. It might be 1.75. I'm not going to get too sticky. If you look at the graph and it appears to be 2, that's what we're going to go with, okay? Nobody's looking for you to figure out that it's 1.3794. Anyways, so the domain does not exist at -1 and at +2, which are also where my two asymptotes are. And it does not appear that I have a horizontal asymptote at all. At least from looking at the graph. Again, I don't have the function to know for sure, but looking at the graph, it does not appear that I have one. So I'm going to leave that blank, or I could write none. Either one is fine, okay? So first we need to be able to look at the graph, we need to find the asymptotes, and we need to state the domain. We also need to be able to look at a function and state the asymptotes as well as the intercepts. So given this function, let's start with our vertical asymptotes. Remember that those are the values that then make the denominator equal to 0. I need to factor this first to figure out what those are. And I can see that I would have a vertical asymptote at 5 and one at 2 because those values would both make the denominator equal to 0. Now remember, horizontal asymptotes have to do with the degree of the numerator and the denominator. If the degree of the numerator is bigger, there's no asymptote. If the degrees are the same, then it's the leading coefficients. And if the degree of the numerator is smaller than the denominator, like it is here, we have an asymptote at y equals 0. Okay? So I don't really have a good way to tell you those rules. You just kind of have to memorize them and know what they are. I will tell you that most of the time, the ones that we're looking at are a horizontal asymptote of 0 because the numerator will be smaller than the denominator. I'm not going to say every single time, but I am going to say most of the time your horizontal asymptote is y equals 0. Okay? Let's find the x-intercept. Remember, the x-intercept is when the function is equal to 0. And for this function to be equal to 0, the numerator would be equal to 0. So we just figure out what value makes 3x plus 4 equals 0. That would be negative 4 over 3. Also remember that the intercepts are points. The x-intercept is when y is equal to 0, and the y-intercept is when x is equal to 0. So I'm going to put 0 in for all three x's, and I'm going to figure out what I have left, which is 4 over 10, which reduces to 2 over 5. That is my y-intercept. You can only have one y-intercept. It's possible to have 2 or more x-intercepts. Again, that has to do with the degree of the numerator. Most of the ones we're looking at, the degree will be 1, so you will only have one x-intercept. It is possible to have 2, okay? Let's try another one. Let's start with our vertical asymptotes here. Again, I'm going to factor the bottom. What values of what factors of 27 and 3? So plus 7 plus 3, which means that I have an asymptote at negative 7 and at negative 3. My horizontal asymptote is again going to be 0, y equals 0, because the numerator is smaller than the denominator's degree, the degrees of the two. My x-intercept, I'm going to make that numerator equal to 0. 9x minus 1 is equal to 0. I'm going to solve that, and I'm going to get 1/9. And then to find the y-intercept, I'm going to put 0 in for all of the x's, and I'm going to get negative 1 over 21. And that's going to be my y-intercept. It's kind of an ugly point. Glad we don't have to graph it. But this is how we find the asymptotes and the intercepts. Again, I would review your notes just to be sure that you're really solid on the rules, specifically for horizontal asymptotes, but for all of this. All right, now we're going to look at a graph. We want to describe the end behavior and the limit behavior of what we're seeing here. So start with the end behavior. The end behavior describes what's happening as it leaves the graph on the right and as we leave the graph on the left, okay? And I'm going to start, I always go from left to right. I don't have a reason other than I just always go from left to right. I find it easier. So looking at the left here, f of x, the graph is approaching 2 from the negative side as x approaches negative infinity. So x is approaching negative infinity to the left. The graph is approaching this asymptote at 2 from the negative side, from the bottom. I'm going to go look at the right, and I can see that it's coming to 2, but this time from the positive side, from the top, as x is approaching positive infinity. That is my end behavior. Now I'm going to look at my limit behavior. What's happening is I'm approaching the asymptote at 5. So I want to talk about this vertical asymptote. Well, again, I'm just going to work from left to right. F of x is going down or approaching negative infinity as x is approaching the asymptote from the negative side. Then if I look at the positive side, the right side, the graph is going up to positive infinity as we're looking at the asymptote from the positive side. Okay? So again, that's my end behavior, or the first two. My limit behavior are the second two. What is happening as the graph is approaching the end to the left and the right? What is it happening as it's approaching the asymptote from the left and the right? Let's try another one. This graph is going to have a bunch of end and limit behavior because I've got a bunch of pieces. So again, I'm going to start with the end behavior, looking at the left side of the graph here. The graph is approaching 2 from the top, so 2 plus, as x is approaching negative infinity. Then I'm going to pop over to the right. Same thing is happening. X is approaching 2 from the top, or f of x, I'm sorry, as x is approaching positive infinity. That's my end behavior. Now I want to work through and talk about my limit behavior. So what's happening to the graph as we're approaching these asymptotes? I have one asymptote at -5, and the graph is going up to positive infinity as I near that -5 asymptote from the left. The graph on the right of the asymptote is going down to negative infinity as I get close to that asymptote from the right, so -5 plus. Now I'm going to jump over to this other asymptote at +5, and I'm going to do the same thing. The graph is going down as we approach negative or +5, sorry, from the left. The graph is going up as we approach that asymptote from the right. That's all of my behavior. So I've got my end behavior, I've got my limit behavior, I have described everything, okay? Make sure that you know the different pieces and make sure that you know how to write it. That 2 plus is important. The -5 minus is important. You need to know how to write that correctly, okay? Let's write an equation here. So we're given the equation f of x equals 5 over x when it's transformed. So we're going to call this g of x because remember it is a different function. And I'm going to keep my fraction. The 5 on the top is going to stay the same. Okay, I'm not shrinking or stretching. So 5 is going to stay the same. On the bottom, I'm moving left, so I'm going to make that x plus 3. Then I'm moving up 4. And I'm doing a vertical flip, which means I need that negative sign with my numerator, okay? My second one, I'm going to do the same thing. This time I'm going to call this h of x because it's yet another function. And I'm going to start the same. So I'm going to start with my 5. And then 2 down means I'm going -2. 7 right means x minus 7. Now I have this stretch of 2, which is going to stretch the 5 by 2. So I'm actually going to erase this. And I'm going to make this a 10. Because I'm stretching that 5 by 2, which means I'm multiplying it. I'm doubling it. So now I have a 10 on the top. I don't have a negative because there's no flip. I just need to stretch that 5 by 2, make it a 10, okay? In addition to writing the equation, you also need to know how to describe the transformations. So it's the same idea, it's just kind of backwards. So let's look at what we've got here. Notice the 3 stays the same, right? So there's no stretch. However, I have a negative, which means I have a vertical flip. This is my h, which means it's moving left and right. In this case, plus means I'm moving left 2. And then this k is -9, which means I'm moving down 9. Those are all of the transformations that have been done. And this is my description. I don't have to do anything more than that, okay? Let's try another one. This time I've got 6 over x. Again, the 6 is staying the same. There's no stretch or shrink. However, I have a -5, which means that I am moving this right 5. And I have a +4, which means I'm moving this up 4. Excuse me. So those are my transformations that are done. I'm just looking at this parent graph, and I'm describing how it changes using my A, H, and K, okay? Now let's get into the fun stuff. We'll do some multiplying here. Remember multiplying, our first step is always to factor, if you can. Looking at this problem, there's nothing I can factor, so I want to move on to that second step, which is canceling. And I'm just going to start canceling stuff. So I'm going to take a 7 out of each of these. I have an x3, so I'm going to take away an x3. I have a y, so I'm going to take away one y. 1y here leaves me with y squared on top. And then 2 x's from here leaves me with x4. Now I'm just going to multiply everything that's left. So if I start on the top, I have 9 times 3, which is 27. I have no x's here and no x's here, but I have 4 y's and I have 2 y's, which gives me a total of y6. And I'm going to go to the numerator or denominator. I have nothing left. I have an x3 and an x4, which gives me an x7. 7. This is my final answer. So I'm just canceling stuff out and I am multiplying what's left. Remember that when you multiply, you add exponents. Looking at this next one here, this is one that I'm going to have to take the time to factor. I'm going to start on the top. I can see that I can take a 3x out of everything, so I'm going to do that. On the bottom here, this is a trinomial, so I know I'm factoring into 2 parentheses. What factors of 10 subtract to make -3? That would be -5 and +2. Then up here I have another trinomial, so I'm going to factor this. Factors of 5 that add to be -6 would be -5 and -1. And then down here, it looks like I can take an x squared out of both of these. And I'm left with 6x minus 1. Now that I've got everything factored, I can start canceling stuff out. I'm going to cancel out the x minus 5s. I'm going to cancel out an x from each of these. And it looks like that's all I have left. So now I multiply 3 times x minus 1 on top. And on bottom, I'm going to multiply x, 6x minus 1, and x plus 2. Okay, as you can see, the order does not matter. Just put the pieces into the new fraction. You do not have to multiply those out. In fact, I would prefer that you did not. Okay, leave it in factored form. Let's try another one. Looking at this one, you can see we're definitely going to have to factor here. Boy, this is a lot. So let's start with how about over here? 15x minus 105. I think I can take a 15 out of both of those. And 105 divided by 15 is 7, right? Now that should be kind of a helpful hint. Looking around, either this one or this one might have an x minus 7 in it. 7 isn't going to 20, so I'm going to come over here. And I see that I can take a 10x out of both of them. So I'm going to do that, which leaves me with an x minus 7. That was kind of helpful. Looking at the bottom right here, this is a trinomial. I need to factor. Now, the first thing I did was I looked to see, can I take a 2 out of everything? Unfortunately, I cannot. But that means that I'm going to have a 2x and an x when I factor this apart. Then I want to know what factors of 20 combined with the 2 get me to 13. So let's try, let's see, 20 is 1 and 20, 2 and 10, 4 and 5. And I need to add up to be 13. Oh, I know. How about 5 and 4? Because 8 plus 5 is 13. Now, looking up to this top left, I can guess that one of these is probably going to be the same, okay? Just because your math teacher loves to make stuff cancel. So I have a 2x squared. I know I'm going to break this apart into x and x. And I'm going to look down here and say either 5 or 4 probably goes into 45. Well, 5 does. I'm going to bet that this is 5 and 9 because that makes 45. I'm just going to see if I get 23. So 5, 18, 5 plus 18 is 23. I know that I have factored this correctly, okay? So use like what you've already factored to try to figure out, because things are going to cancel. They're going to be the same on top and bottom. In fact, I'm going to cancel these 2x plus 5s. I'm also going to cancel the x minus 7s. And I'm going to divide a 5 from 15 and 10. And I don't think there's anything more I can cancel, so I'm just going to write what's left. On top, I have 3 and x plus 9. On bottom, I have 2x and then x plus 4. And that is my final answer. So I multiplied through after factoring and canceling. We also need to be able to divide. And remember, dividing means that you flip and multiply. So this becomes 6y cubed on top and 24x5y on bottom. And then I'm going to change this from division to multiplication. Okay? Now I can go through and start canceling everything. So I am going to cancel, let's see, 16 and 24 can both be divided by 8. 6 and 9 can both be divided by 3. I've got 1x here, so I'm going to take 1 from there. I've got, let's see, a y3 here and a y here, so I'm going to take 1 from there. I don't see anything else. Let's multiply what we have left. So 2 times 2 is 4. Then I've got y5 and y2 is y7. On the bottom, 3 times 3 is 9. And I've got x2 and x5 is x7. There's nothing I can simplify with either of those. So that is my final answer. I am done. Now on the last one, I didn't have to factor. On this one, clearly I do. So I am going to flip this fraction, and I'm just going to factor on top and on bottom. Okay, so this x squared minus 7x plus 12, I'm going to factor up here. The factors of 12 that add to be 7, -7 are -4 and -3. And then on the bottom here, I'm going to factor this 3x squared minus 9x minus 30. First of all, I'm going to take a 3 out of everything, which leaves me with x squared minus 3x minus 10. And then I'm going to factor that into x minus 5, x plus 2. I'm going to change this to multiplication. I'm just going to cross these off because I've already done them. I'm going to go over here on the left-hand side and I'm going to factor this. What factors of 12 this time subtract to be -1? -4 and +3. And then on the top here, I can take a 9x squared out of both of these, leaving me with x plus 2. Now that I've got everything factored, I'm going to go through and cancel stuff. So I'm going to cancel the x plus 2s. I'm going to cancel the x minus 4s. I'm going to cancel a 3. I think that's it. So let's multiply what we have left. On top, we have 3x squared times x minus 3. And on bottom, we have x plus 3 times x minus 5. There we go. That is done. So once we get it factored and canceled, we multiply what's left. That is our final answer. I always check just to make sure I didn't miss anything. That could also be canceled out more, but usually we're pretty okay. All right. Let's try one more division one. I'm going to flip the second one. I'm going to factor the 25x minus 50 on top. And then on the bottom, I'm going to factor the x plus 2x minus 15. And I'm going to change the division to multiplication. Then I'm going to come over here on the left, and I'm going to factor this. This plus 3x minus 10 keeps showing up a lot, huh? So we should be pretty good at factoring that by now, I hope. And then on the bottom here, I'm going to take in 5x out of everything, and I get an x minus 9. Now I'm going to start canceling. So I can cancel x plus 5. I can cancel a 5 and the 25, and it looks like that's it. So on top, I am left with 5 and then x minus 2 squared because I have 2 of them. On bottom, I'm left with x and x minus 9 and x minus 3. That is my final answer. Let's do some adding and subtracting. Remember, this is where you have to have a common denominator. So I'm looking for a common denominator for 7 and 4x. There really isn't anything they have in common, so I'm just going to multiply them to make 28x. Okay? Now, 7 times what gives me 28x times 4x. So I'm going to multiply 4x times x minus 2, which is 4x squared minus 8x. Over here, I'm going to multiply by 7, which gives me 63. Then I just combine any like terms, which actually there are not any. So I'm just going to multiply this out, or add this out, sorry, and put it all over 28x. So 4x squared plus 8, or minus 8x plus 63, all over 28x. Let's try another one. Remember that sometimes it's helpful to factor first. This didn't really help me because they still have nothing in common. So I'm just going to make my common denominator 3x plus 2, x minus 2. Now I'm being a little lazy here. I'm not going to write two separate fractions. I'm just going to put it all together into one fraction and then simplify from there, okay? So I'm still doing the same thing. I'm just writing it as one fraction because I don't feel like writing it over again. So on this 5x over here, I'm going to multiply by 3x plus 2, or 3x plus 6, which I already know that's what that is, times 5x is going to give me 15x squared plus 30x. Then over here on the right-hand side, I'm going to multiply by x minus 2. Now remember, I'm multiplying the quantities. So this is where I'm going to need my box to multiply 9x minus 7 times x minus 2. And I'm going to multiply that whole thing out. And I get 9x squared minus 25x plus 14. And I included parentheses because I'm subtracting that whole quantity. And I want to make sure that I don't forget to subtract anything. So I always put it in parentheses just to be sure that I don't forget. So let's combine like terms, okay? So I've got 15x squared minus 9x squared is 6x squared. 30x minus negative 25x is plus 55x. And then I'm just going to minus the 14 all over 3x plus 2, x minus 2. The top, I don't think is factorable, so I'm just going to leave that alone. I can't take anything out, so that is my final answer. Same thing here, we want to add or subtract this. These clearly have no terms in common, so that is going to be my common denominator, x plus 1 times x plus 4, which means I'm going to be multiplying the left by x plus 4 and the right by x plus 1. 9 times x plus 4 is 9x plus 36. 4x times x plus 1 is 4x squared plus 4x. Notice I'm using parentheses again because I'm subtracting that whole quantity. So I'm going to go ahead and do that, negative 4x squared, and then 9x minus 4x is 5x plus 36 all over x plus 1, x plus 4. There's my final answer, okay? I probably should check the discriminant just to see if this top is factorable, and I get 25 minus plus 4 times 36, whatever that is. 4 times 36, 144 times 4 is 400, 560, 576. And then if I add those together, I get 5601, which does not have a square root. So this is not factorable, okay? So just checking the discriminant real quick to make sure that I can't factor it. 9 times out of 10, you're not going to be able to. But I just wanted to make sure. Adding and subtracting leads us to solving because it's kind of the same process. You're multiplying by a common denominator. So in this case, my common denominator is going to be 5x minus 2. And I'm going to multiply each of the fractions by that, by kind of by what they're missing, okay? So like in the first fraction, the x minus 2's cancel, and I have 5 times x, which is 5x. In the second fraction, the 5 cancels, and I'm left with 1 times x minus 2, which is x minus 2. On the third fraction, the x minus 2's cancel, and I'm left with 2 times 5, which is 10. I'm going to combine like terms, and I'm just going to solve. So I get 6x, and then I'm going to add 2 to the other side equals 12, x equals 2. Now remember that when you're doing this, you want to plug this back in just to make sure it's not an extraneous solution. When I do that, I get 2 minus 2, which is 0. That's going to make this denominator 0. Therefore, I have no solution. Please check your answers. just to make sure that they, number one, work, but number two, don't get you a denominator that is 0. If they do, then they are not a valid solution. You cannot include them as a solution, okay? Please don't forget to check your answers. This time, we're going to multiply by a common denominator, which is going to be x minus 1, okay? And let's just multiply that out. So on the first fraction, I'm going to multiply x by x, which is x squared. On the second, I'm going to multiply 2x, or 2, sorry, times x minus 1, which is 2x minus 2, but because I'm subtracting, it becomes plus 2. And then on the last fraction, I'm going to multiply 1 times x, which is x. I am going to make this equal to 0 because this is a quadratic. I am going to factor because I know that 2 times 1 equals 2 and 2 plus 1 equals 3. Therefore, my solutions are x equals 2 and x equals 1. When I plug these back in, I get 2 over 1 minus 2 over 2 equals 1 over 1. 2 minus 1 equals 1. That checks. When I put the 1 in, I get 1 over 0. I'm going to stop right there. I know that doesn't work. Therefore, 1 is not a valid solution, and x equals 2 is the only solution of this problem. Please don't forget to check your answers. That's very, very important. Now, on this one, I'm going to want to factor in order to be able to see what my factors are that I'm working with, okay? And I can see that my common denominator is going to be x minus 3, x plus 2. Which means that on this first fraction, they both cancel, and I'm left with 3x plus 13. On the second fraction, the x minus 3's cancel, and I'm left with 4 times x plus 2, which is 4x plus 8. And remember we talked about it's okay to write all this out if you want to see it and then cancel stuff. I'm a little limited on space because my screen is only so big, and so I can't necessarily write everything out. So I'm trying to talk through what's canceling without actually writing it down for you, okay? On this third fraction, the x plus 2's would cancel, and I'd be left with 1 times x minus 3, which is x minus 3. Now I'm going to combine like terms and solve. So I am going to start by putting my x's together here. I get 5x minus 3x is 2x. And then I have 8 minus 3 is 5. 13 minus 5 is 8. Therefore, x equals 4. 4 minus 3 is not 0. 4 plus 2 is not 0, so I'm good there. Let me plug this in just to make sure that it works. So 3 times 4 is 12 plus 13 is 25 over 4 squared is 16. 16 minus 4 is 12. 12 minus 6 is 6. 4 over 4 minus 3 is 1, so that's 4. Plus 1 over 6 is 1/6. And 4 plus 1/6 is 4 and 1/6, which 25 over 6 is also 4 and 1/6. So that checks. So 4 is my solution. Again, you should always check your answer. Just make sure it's not extraneous and make sure that it actually works. Occasionally you have something where you mess up a negative or something, and it will mess up your whole problem. I will tell you, I was trying to write a question for the test, and I had changed it to a minus, and I kept trying to plug my answer in, couldn't figure it out, wouldn't work. And I finally figured out I just messed up one of my minus signs. So be really careful about checking your answers so you know that you did it correctly, okay? We have one more here. Again, we're going to factor. I know that 8 times 5 is 40 and 8 plus 5 is 13, which means that x plus 8, x plus 5 is our common denominator. It's kind of fun how that works out that way, huh? It's almost like your teacher has a plan when she's writing these problems. Anyways, I'm going to multiply this first fraction by x plus 8 because the x plus 5 would cancel. 5 times x plus 8 is 5x plus 40. 3 I'm going to multiply by x plus 5 because the x plus 8s would cancel. That gives me 3x plus 15, but remember I'm subtracting, so I'm going to write minus 15. really careful about this sign here. It can mess up a lot if you don't forget to subtract that second piece, okay? Then over here, I'm not going to multiply the 7 by anything because both of those pieces cancel out with the denominator. Now I want to combine like terms. So I'm going to get 2x here. I'm going to add 15 and I'm going to subtract 40. So 7 plus 15 is 22. Minus 40 is negative 18. Divide and x equals negative 9. I know that I'm good on my denominators because negative 9 plus 5 and negative 9 plus 8 are not 0. Then I want to just go through and check this to be sure that it works. So 5 over 4 minus 3 over negative 1, negative 4, my bad, equals 7 over 81 plus 40 is 121 minus 107. 121 minus 107 is 14, right? So negative 5/4 plus 3, which would be 12/4. 12 minus 5 is 7. So we get 7. So I think that checks. Again, my mental math might be a little off, but I'm pretty sure that it checks. So x equals negative 9. I hope that I checked that correctly and that my mental math is on tonight as I'm doing this. If not, we'll discuss it in class tomorrow, or feel free to call me out and say, hey, you did this wrong. This is what it should be. Happy to answer those questions or fix those problems, okay? Please make sure that you're studying for your test. Please make sure that you're doing these problems. Be ready, okay? Study it up. Always think positive when you come to a test. You know what you're doing, okay? Have some confidence in yourself. You've prepared, you're ready, you can do this test, and then just be awesome, and you will achieve total success on your test. I know you can do it. You guys are great. Again, if you have any questions, let me know, okay? I'm happy to help. Take care, and we will continue talking about this in class.